Hi guys, hope all of you are doing great. We're going to look at one of the last bits of the discussion on logarithms and the logarithmic functions, or rather logarithms and logarithmic functions. And we're going to look basically at the transformation of our basis in logarithms, which is going to form our basis for us in trying to figure out how we can be able to change a basis of logarithms. Now that we have described the concept of basis in logarithms, we're going to use just a general example of trying to find out how we can be able to achieve this. Now, suppose we wish to change logarithm to base a of a number n to logarithm to base b of that particular number. So n is an arbitrary number that we're going to just use in this specific case. So therefore, we are going to have this one represented as an expression, whereby we're going to see that we can be able to represent a log to base bn as a number which is given as y. This is going to have an implication of an exponential function, whereby we are going to have an exponential notation, whereby we're going to have b raised to power y, which is going to give us that number n. So therefore, we're going to use this one in trying to see how we can be able to change logarithms. We had worked in our last bit of a natural logarithms, we had worked in one of the examples and found a general formula of representing natural logs of numbers. And we're going to use the same strategy and try to find out how we can be able to achieve a transformation of basis in logarithms. So therefore, in this case, we're going to introduce logarithms on both sides of the expression, perhaps log to base a. So therefore, we're going to have log to base a of b to y is going to be equivalent to log to base a p of n, so that we can be able to achieve this particular expression. So we're going to have this from the logs of our logarithms y, log to base ab is equivalent to log to base an. And in this case, we're going to divide both sides by log to base a. So log to base ab, log to base ab. And we are decided that let in this case, of course, we had decided our y, which was a number we had introduced. Of course, in this case, we say that let log to base bn be represented by the number y. So this is where we started our transformation. So in this case, we know the value for y. Therefore, we're going to do a substitution in this case, whereby this logarithm to base log of b to base a is going to cancel out in our left part of the expression. Therefore, we're going to have log to base b n being represented as, which is basically the value for y, being represented as log to base n over log to base a b. So that is going to be the implication of that, whereby we have transformed log to base a into log to base b, or rather log to base b into a log to base a, which is going to be represented as such. So therefore, this is one general strategy that we're going to use in transformation of other logarithmic expressions, which we are going to encounter later, perhaps by using specific examples. So I hope that one is going to, of course, in collaboration with other discussions that we have had with logarithms, going to assist us, of course, in trying to figure out how these specific concepts can be applied whenever we come across them. So we're going to wind up there. So I think that one forms the last bit of our discussion for now. Of course, we're going to have other topics, especially on the application side of logarithms, which are going to be used, or rather have application for whatever we have discussed. So that is now that's it for now, guys. Bye. God bless you.